Okay, so when I first read Challenge 5, which was Kendall's Donuts came in boxes of 6, 9, or 20, what is the largest number of Kendall's Donuts you cannot buy? So I assumed it was a logic question, and since 6 and 9 have a common factor of 3, I figured that might help me in solving the problem. So then my next step was I just started listing off multiples of 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33. And then once I listed all those, I started listing a few ways I could reach, I guess, different numbers of donuts you could buy. So for example, you see here 1 box of 6 is 6, 3 boxes of 6 and 2 boxes of 9 would come out to 36. 3 boxes of 6 and 1 box of 9 would be 27. So then I wrote any number divisible by 3 can be purchased, but not the number 3 because it's too small. So you couldn't buy like a box of 6 donuts and then just take out 3. You'd have to buy at least a minimum of 6. So then some equations I came up with that I could maybe try to use to attempt to solve this problem was x square root 3 divided by 2, or x square root 3 plus 20, which neither of those actually ended up helping me solve it. In the end, I found a different way to work out the problem. So here, I wrote what I just said. You cannot get a box of 3 by itself. So I started listing numbers 1 to 70. I could have gone higher, but instead of writing them all on my paper, I kind of did some of them down here to check some of my work. But so I went through, and since the minimum number of donuts you could buy is 6, I circled 6. And then the numbers that I didn't circle were amounts of donuts that you could not purchase. If they have an underline in a circle, that means that they're divisible by 3, 6, or 9. So 6 is circled, 7, 8 is not. Then you could purchase a box of 9. 12, because you could purchase 2 boxes of 6. 15, a box of 9, a box of 6. 18, 3 boxes of 6 or 2 boxes of 9. 21. And then I put a line here because after this, it's basically numbers divisible by 3 plus 20. So 23 is a box of 20 plus it's divisible by, or it, like, you just add 3 to it. So it's not circled because you just couldn't buy a number of boxes to equal 23. 24 is circled. 26, so a box of 20, a box of 6. 27, because that's 3 boxes of 9. 29, a box of 20 and a box of 9. 30, 5 boxes of 6. And I mean, you can see what I'm kind of doing down here. Down here, 40, I guess I should have circled that one because you can purchase a box of 40. So let me do that now, if I can see. Oops, I dropped my phone. 41, because you could do a box of 3 boxes. I can't. Well, 27. It's a box of 6. I'll have to do the calculations for that one, but I'm pretty sure you can do a box of 41. And so then I noticed that after the number 43, I was just continuously circling all these numbers, and I double checked a lot of them on another sheet of paper, but once I circled about 25, I mean, as you can see, I kind of realized that maybe 43 was the number I'm looking for. It is the last, or the greatest amount of donuts I could not buy, because then after that, like, it's possible to put 6, 9, 20 numbers that are divisible by 3 together to buy these donuts. So down here I kind of showed some of my work. 63 would be, because I took 2 numbers that were kind of questionable to me, and so down here I wrote, okay, well, to get 63 you could do 2 boxes of 9, 4 boxes of 6, and 1 box of 20, and that would equal 62. And then 65 would be 3 boxes of 9 plus 3 boxes of 6 plus 1 box of 20, and that was 65. So yeah, I kind of just worked it out this way, and so my answer would be 43.